Okay, this is a video about finding volumes of revolution by cells or cylindrical shells. And you can find better videos and probably explaining it better on Khan Academy and YouTube and all those places, but I'll give you one example here of why we do it and how we do it. So if we would take 3x minus y squared, wrap it around or revolve it around the y-axis, we would end up with something that looks about like this, very roughly. We'd rotate it around, and what it would turn out looking like is, say, a bunk cake or anything like that for all you foodies out there. And if we look at that, inside there we can look at it as a cylinder. And the reason we're going to look at this as a cylinder is if we tried to slice it horizontally, our radius on the inside would be the same equation as our radius on the outside. So outside minus inside is not going to work on a washer method. So because we can't do the washer method, we're looking at the cylindrical shells method. So think of a roll, can't use toilet paper because it's such in short supply, but a roll of paper towels wrapped up is many different circumferences times the thickness of each piece of paper. So we can find the volume that way. So we're looking at circumference times thickness. So that turns us into the volume is equal to 2 pi RH times the thickness. So if I go back here and I look at this line I got right here is actually, its thickness is dx. So we can have 2 pi RH thickness dx. And we've kind of realized that using dx is a little easier than using dy anyway. 2 pi is a constant. Now if we look at our radius at any spot here, our radius from the center out there is always going to be our x value. I got dx here, I got x there, so our radius is x. The height of all these cylinders, which this one would go all the way up and over, is our y. And our y is actually equal to 3x minus x squared. So notice that we didn't have to solve for anything in particular. Our radius is going to be our x, that's pretty straightforward. Our height's going to be our y, looking good. Got the dx, and we want to add them all together. And while we're adding them all together, we're going to start with a radius of 0 down there, and we're going all the way to 3. So 2 pi 0 to 3, let's go 3 x squared minus x cubed dx. Now, I'm going to leave the rest of this up to you because you don't need to sit there and watch me do another one of these problems. And that's very straightforward integration. I hope this video finds you well. It's probably time for you to get to work. I'll give you a little more directions. But for now, T-Lou out.